5.3, proving triangle congruency. Proving triangles congruent to column or flowchart proofs. So this first example, we are given some information. We are given that M is the midpoint of segment RT and that segment SR is congruent to segment ST. What I do first when looking at this is I go ahead and label in my picture all of the information that I can. Okay, so M is a midpoint of RT. We'll get to that here in a second. But I know that SR, or segment SR, is congruent to segment ST. So let's go ahead and put that on our picture. So SR, that segment is congruent to ST. So here in the proof, we are talking about definition of midpoint. This is a flowchart proof. So we were given that M is the midpoint of segment RT. So that's one piece of information that we were given. The next box says definition of midpoint. So if you recall what a midpoint is, it is a point that cuts a segment exactly in half. So if this is the segment RT that we're talking about, this point M cuts that segment exactly in half. If it cuts the segment exactly in half, this side has to be congruent to this side. Notice how I went to using 2 dashes because 1 we already used. So then here I can say that segment RM is congruent to segment MT. And that's a definition of midpoint. Down here, my next box says segment SM is congruent to segment SM. So this is what we are talking about with the reflexive property. It appears SM is in both triangles. Since we are setting something congruent to itself, it's like you're looking in the mirror, so it is the reflexive property. Go ahead and label it in your picture as well. I'm going to use 3 dashes because I already used 1, I already used 2. We were also given that segment SR is congruent to segment ST. That's our second piece of information that we are given. Then if I look at my picture, I have a side congruent to this side's congruent to that side, and side. Now you can see it is side, side, side congruence. All right, our next proof, we are given that ray BD bisects angle ABC, and we are given that segment AB is congruent to segment CB. So our first statement, ray BD bisects angle ABC, that was given to us. Angle bisector. If something bisects an angle, it is cutting that angle exactly in half. So if I have, let me see. If it is cutting ABC, here's angle A, BC, it is cutting that angle exactly in half, which means this angle is now congruent to this angle. It's cutting the angle exactly in half. So when I go to name it, I can name it as angle A, B, D. So angle A, B, D is congruent to angle C, B, D. And that is the definition of angle bisector. I know it's an angle bisector because we are bisecting an angle, and an angle bisector cuts that angle exactly in half. We were also given that segment AB is congruent to segment CB. That was given to us. Let's go ahead and label that in our picture. AB, this segment right here, is congruent to CB, that segment right there. Our next statement or reason says reflexive property. I see that they're sharing the side BD, which means that BD is congruent to itself of BD. So I'm going to mark that with 2 dashes because 1 has already been used. And then our last line in our proof is whatever we are trying to prove. Here we are trying to prove that triangle ABD is congruent to triangle CBD. Reason why? Well, here, if you still need a label, go ahead. Side congruent to that side. This angle is congruent to that angle. That side's congruent to that side. Here I can see I have SAS, SAS. So it is going to be SAS congruence. On the back, segment GE bisects angle DGF and angle DEF. And that is our first statement, so that is given to us. Okay, so here, GE, which is this segment right here, bisects DGF. That means it cuts this angle exactly in half. So, cuts that angle exactly in half. This angle is congruent to that angle. To name that angle DGE, so DGE, again, you have to use 3 letters here, is congruent to angle FGE. Why? That is the definition of angle bisector. And then again, it also says that GE bisects angle DEF, so it cuts this angle exactly in half. Notice how I'm using 2 arcs now because I already used 1 right over here. Now I have to name those 2 angles. So DEG, angle DEG is congruent to angle FEG. Again, you have to use 3 letters because at E and at G, there are 2 different angles. So if I say angle G, you do not know what angle I am talking about. That's why we are using 3 letters. And that is, again, the definition of angle bisector. What else do we need? Well, I need 3 pieces of information, and I only know 2 of them. However, I see that they are sharing this side. When they're sharing a side, that's reflexive property. So I can say that GE is congruent to GE by the reflexive property. And then our last line is always what we are trying to prove. And here we are trying to prove that triangle GDE is congruent to triangle GFE. Why? Let's look. Here I have an angle and an angle, another angle and another angle, and a side and a side. As you can see, that is angle, side, angle, angle, side, angle. So this is going to be angle, angle, side, angle, congruence. All right, we have another flow chart proof. On this flow chart proof, we are given that AB is congruent to CD. So AB, this whole side right here is congruent to CD, right there. And angle CDB is congruent to ABD. And we are proving that triangle ABD, so triangle ABD, this triangle right here, is congruent to CDB. CDB. I feel like for this one, let's go ahead and separate our triangles. That's going to be easier for us to see. So I am going to say it is easier to see if you draw Okay, so it's easier to see if you draw the two triangles separate. So let's go ahead and do that. I'm going to draw triangle ADB, and I'm going to have triangle CBD. Okay, so we are given that AB is congruent to CD. So AB, let's go down to our picture that we drew. So AB is congruent to CD. And we are given the angle CDB. So angle CDB, this angle right here, is congruent to angle ABD. So this angle right here. Let's write that in our proof. So in our proof, I'm going to put that first box, first piece of information that we are given, segment AB is congruent to segment CD. Why? Because we were given that information. We were also given that angle CDB is congruent to angle ABD. That was given to us. All right, so I need another piece of information to prove these triangles congruent. One thing that I see is if you look here, DB occurs in that triangle, DB occurs in that triangle. Since they are the same segment, that is the reflexive property. So segment DB is congruent to segment DB by the reflexive property. So, two dashes, let's see what this is. I have a side and a side, angle, angle, and a side, side. Now I can see a little bit better that is side, angle, side. We are trying to prove that triangle ABD is congruent to triangle CDB. And we said it is by side, angle, side congruence.